All right, so we are going to go through the review for Unit 6. I don't know, this shouldn't say Unit 8, but whatever. So first off, what is the difference? Sorry. What is the difference between a reactant and a product? So I'm not going to write this down. I'm just going to kind of talk about it. So a reactant is the starting point of a chemical equation. Okay, so the stuff on the left side, the stuff that mixes together to make the result of the product, which brings us, I'm sorry, the result of the equation, the reaction, which brings us to the product. The product is the result of the equation, the reaction. Okay, the stuff on the right side, the stuff that after the reactants mix together, they form. Okay, so reactants are the beginning, products are the end. Reactants on the left, products on the right. The four states of matter and how they are represented in a chemical equation. Okay, so that is solid, and that is represented by an S in parentheses. We have liquid, we have gas, and we have aqueous. Okay? So, solids, liquids, and gases, those are pretty self explanatory. Aqueous means to be dissolved in water, okay, or in solution. So, those are how we represent those in a chemical equation. If we had, let's say, NaCl, okay, if that was aqueous, then we would put aqueous as a subscript in parentheses like that. Okay. All right. So next, we are going to make some word equations. Okay. Aqueous potassium chloride is mixed. Sorry. Aqueous potassium chloride is mixed with aqueous silver nitrate to produce aqueous potassium nitrate and solid silver chloride. So potassium chloride, that's K. K has a +1. Chloride is Cl, that has a -1. So you put those together, that's KCl. That is aqueous, so it's going to be like that. Mixed with, so that's our plus, silver nitrate. So silver is, oh, I should probably make it an actual capital. Silver is Ag, that has a +1 charge. Nitrate is NO3, that has a -1 charge. So that's going to be AgNO3. To produce, oh, and that's aqueous. So to produce is our arrow. Potassium nitrate. So K is still +1. Nitrate is still NO3 -1. So that's just going to be KNO3. And that is aqueous. It's not a very good A, but you get the idea. And solid silver chloride. So silver is still Ag +1. Chloride is still Cl -1. So that gives us, I forgot to write the plus there, AgCl, and that is a solid. So we put an S there. Okay. Now, this, after we count everything, it is all balanced already. So there's 1K, 1K, 1 Ag, 1 Ag, 1 NO3, 1 NO3, 1 Cl, 1 Cl. Okay, so everything is already balanced, so we don't have to worry about that for this one. Next one, a solution of aqueous potassium bromide. I'm sorry, yeah, potassium bromide breaks down into potassium metal and elemental bromide. Oh, and also, I don't think it actually says this in the directions, but we are going to classify this reaction. This reaction is a double replacement reaction. There's more on that later, so that's why I'm not really going into detail. So a solution of aqueous potassium bromide breaks down into potassium metal and elemental bromide. So we have potassium bromide. Potassium is K +1. Bromide is Br -1. So those are going to be put together, KBr. That breaks down, so that means that's an arrow, into potassium metal. So potassium is just K. Oh, and I forgot to do states of matter. So this is aqueous because it says aqueous there. Potassium metal. So potassium metal is going to be a solid. All solids are metals except for one, and that is mercury, which this isn't mercury, so it's solid. And then elemental bromine. So that's plus. So Br, and bromine is special. It is part of the high 7, the diatomic elements. So that's going to be Br2. Okay. And bromine is also one of the only 2 liquid elements on the entire periodic table. So there is that. Okay, so next we got a balance. The only element that's not balanced, I guess there's only 2 elements, but the element that's not balanced is the Br. We have 2 Brs on the right, 1 on the left. So we can put a 2 there. Now we have 2 Ks on the left, 1 K on the right, so we can put a 2 there, and now it is balanced. And this is a synthesis. I'm sorry, not a synthesis. This is a decomposition reaction. Okay, opposite of synthesis. All right, so next, iron metal is placed into a solution of copper 2 sulfate. The result is a solution of iron 2 sulfate and copper metal. So iron metal, that is just straight iron, Fe. Okay, and that is a solid because iron metal is a solid. Also, it says in the periodic table. Plus copper 2 sulfate. So copper is Cu, that has a charge of +2 because of the Roman numeral. Okay, and then sulfate is SO4. -2, that is a polyatomic ion, and therefore on the charge chart. So those charges are going to balance each other out. So it's just going to be CuSO4. And that is going to be in solution, which means aqueous. The result means we do our arrow. A solution of iron 2 sulfate. So iron +2 because of the Roman numeral. Sulfate, again, is -2. Excuse me. So that's just going to balance out. So it's going to be FeSO4. That is in solution. So that's aqueous plus copper metal, which is Cu. And copper metal is a solid. All right, next, sodium metal reacts with water vapor. So sodium metal is just straight sodium. That is a solid. Also, I didn't specifically say this on here, but when we have a element, just a straight element that's not bonded to anything, it is neutral. So that's why, like when we had straight iron and straight sodium here, I didn't worry about charges because they are not bonded to anything, so they don't have a charge. They're just neutral. Okay. So plus water vapor. So water vapor is H2O gas, because that's what a vapor is. In the air to form solid sodium hydroxide. So sodium is +1. Hydroxide is OH -1. Okay. Oh, and I forgot to say this, but the iron this one up here. Okay, that is already balanced, so that's why we did not balance it. So OH is -1, so those are going to balance out. NaOH, and that is a solid because it says there. And hydrogen gas. Okay, so hydrogen is H, but hydrogen is part of the high 7 diatomic elements. So that's going to be H2, and it does say it's a gas. Okay, now this is a balancing. This one is, I believe, also. Oh no, it's not balanced. Never mind. Okay, so we're gonna have to actually balance this one. So we have hydrogen in 2 different places. So the best way in 2 different places on one side. So the best way to do this is to save that for last, except we can't because all the other ones are already balanced. So we can't save it for last, but we do have an odd number of hydrogens. Okay, so we have 2 hydrogens here. We have 1 hydrogen here, so that's 3 hydrogens. So that's bad. We don't really like odd numbers. Okay, so to get rid of an odd number, the easiest way to do that is to multiply it by 2. Okay, so I'm going to put a 2 right there. So that will now double our amount of NAs, Os, and it will double this H. So now we're going to have 4 total H's. So we got rid of our odd number of H's. Hooray! So we can now balance our H's. We can put a 2 there. Now we have 4 H's, and that also balances our O's. And now all that's left is to balance the NAs. So we can put a 2 there, and now our NAs are balanced. Now, this is a single replacement reaction because we'll talk about why those are later on. And also, I forgot to identify this number 5 up here. That is also a single replacement. Okay. All right, last one of these. Sulfur trioxide in the air reacts with water vapor. So first we have sulfur trioxide. Now, sulfur trioxide is a covalent compound because it has tri in it. That's how you would know. So that's nice and easy. We just do sulfur. There's one of them because there's no prefix. Trioxide is O3 because tri means 3. Sulfur trioxide. So this one is a little bit tricky to figure out what the state of matter is, but it says sulfur trioxide in the air. So that kind of tells you that since it's in the air, it is a gas. That reacts with water vapor. So that is also a gas to form aqueous hydrogen sulfate. So we have hydrogen. That is a +1. We have sulfate. That is a -2. So we need to balance that out by doing H2SO4. And that is aqueous because it says aqueous right there. Okay. So now we need to balance, but I think this is already balanced, and yes, it is. So that's already balanced. So now we need to identify. Okay, this is a synthesis reaction. Okay, moving along. What is the law of conservation of matter? Again, I'm not going to write this, but I'm just going to say it. The law of conservation of matter states that matter cannot be created nor destroyed. So, as far as how that affects equations, anytime we have an element on one side, we have to have that same element and in the same amount on the other side. Okay. If we have Ba on one side and we don't have the same amount of Bas on the other side, that means we either created or destroyed matter, which we can't do. So that is the whole purpose of balancing equations, is so that we're not creating or destroying matter. Okay. So now we're just going to balance all of these equations. So first one is a pretty easy one. Most things are already balanced. So we have 1 Ba, 1 Ba, 2 NOs, 1 NO, 2 Ks, 1 K, 1 SO4, 1 SO4. So the only thing that's not balanced is K and NO3s. And look at that. We have these two NO3s, or I'm sorry, K and NO3 right over here together. So we just need a 2 right there. We can replace the rest of these with just a 1. And now it is balanced. So next, we have to identify this. This is a double replacement reaction. And the reason it's a double replacement reaction is because the Ba switches places with the K. The NO, excuse me, the NO switches places with the SO4. Okay, so the Ba then bonds to the SO4. the K bonds to the NO3, so both of them switch places, and that's what a double replacement reaction is. Two different parts switch places, okay? All right, next one. We have 2 C's, 1 C, 5, 6 H's, and we have 2 H's, and we have 1, 2, 3 O's, 1, 2, 3 O's. Okay, so this is not balanced. So again, like I was saying before, but it didn't kind of work out that way. When you have something in two different places on one side, it's best to save it for last. So these oxygens that are in two different places here, okay, we're just going to save those for last. We're going to balance other stuff first. So first we'll balance the carbons. Okay, we have 2 carbons here. We have 1 carbon here. So let's fix that. We can put a 2 there, and that will balance out our carbons. Okay, that's also going to throw off our oxygens a little bit even more, but that's okay because we're next going to do our hydrogens. Okay, we have 6 hydrogens over here. We have 2 hydrogens over here. We can put a 3 right there, and now our hydrogens are balanced. Okay, so now we have 3 oxygens here. I'm going to erase this so it's not confusing. So we have 3 oxygens here. We have 4 oxygens here. So that is a total of 7 oxygens. Okay, so that's going to be a little bit tricky, but remember, we have our 1 oxygen right here. So we only need 6 oxygens from this one right here. So we can just put a 3. And now we have 7 total oxygens on the left side, 7 on the right side. Okay. All right, so it's all balanced. Now we have to identify. Okay, this has oxygen, carbon dioxide, and water. That makes it a combustion reaction. All right, next one. Next one's super easy. We have 1 Fe, 1 Fe, 1 Cu, 1 Cu, 1 SO4, 1 SO4. So it is already balanced. So we can just put ones on all of those. Oh, and I forgot to put a 1 up here. Okay, cool. And also, when we have polyatomic ions, okay, I can't remember if I said that in, I did that up here too. But when we have polyatomic ions, as long as the polyatomic ions stay the same on both sides, you can treat them as one thing. So what I mean by that is here we have SO4. Here we have SO4. If we had SO4 on one side and SO3 on the other, then we wouldn't be able to do that. But since they are both the same on both sides, then we can just count them as one thing. Okay, so this is already balanced. Now we just need to identify. This is a single replacement reaction because the Fe comes in here, replaces the Cu, bonds to the SO4, okay, and kicks the Cu out. So this is a single replacement reaction because one element is getting replaced. Single replacement. All right, next one. We have 2 hydrogens, 1 oxygen, 2 oxygens. Okay, so let's balance our oxygens. 2 oxygens there. So now that doubles our hydrogens. So we put a 2 there for our other hydrogens. Now we're balanced. Hooray. Put a 1 in the empty space, and now we classify. This is a decomposition because we start with 1 reactant, we end with 2 reactants. So decomposition. All right, now, next one is a little bit tricky, okay? So first off, we have oxygen in 2 different places. So we're going to save that for last. So let's start with our carbons, okay? We have 2 carbons on one side. We have 1 on the other. So we can fix that. Put a 2 there, okay? So now our carbons are good. Okay, so now let's go to our hydrogens. We have 6 hydrogens here. We have 2 here. We can put a 3 there. Okay, now our hydrogens are good. Okay, so now we go to our oxygens. How many oxygens do we have? We have 4 here. We have 3 here. So we have a total of 7. Well, that's a problem, right? Because we need 7 from this one oxygen right here. If we put a 3 here, that only gives us 6. If we put a 4 here, that gives us 8. Neither of which are correct, and we can't use decimals, right? So what we're going to do here, this is another odd number, right? Odd numbers are generally not good in balancing. You don't want odd numbers. So the easiest way to get rid of an odd number is to multiply it by 2. So what we're going to do here is we're going to go back from where we started with our C2H6, and we're going to multiply it by 2. We're going to put a 2 in front of that C2H6, which is going to change these. So now we have 4 carbons on the left side. So we're going to put a 4 there. So now our carbons are good again. We now have 12 hydrogens on the left side. So we're going to put a 6 here. So now our hydrogens are good. So now we have 6 oxygens here, and we have 8 oxygens here. That's a total of 14 oxygens, which now that's an even number, right? So we can get 14 oxygens from this one by putting a 7. Okay, and now it's balanced. Hooray. Okay, now we have to classify. This is a combustion reaction because we have so oxygen is a react. Oh, geez, sorry. Oxygen. Oh my gosh, what is happening? There we go. Oxygen as a reactant, carbon dioxide and water as a product. So that is a combustion reaction. Okay, next one. We have 1 CS on this side, 1 CS on that side, 2 BRs on this side, 1 BR on this side. So 2 to fix the BRs. Now we have 2 CSs, 2 to fix the CSs. Nice and easy. Okay. And then classifying, this is a synthesis reaction because we are starting with 2 things. They come together to make 1 thing, and that is a synthesis reaction. Hooray. All right. Next one. K2SO4. All right. We have 2 Ks on the left side. We have 1 K on the right side. We have 1 SO4 on the left side. We have 1 SO4 on the right side. 1 Ci on the left side. 1 Ci on the left side. 2 Cls on the left side. 1 Cl on the right side. Okay. So the only thing that's not balanced is the Ks and the Cls. And those are together in 1 compound. How convenient. We put a 2 there, and now we're good. We fill the rest with 1s. There we go. So now classification. This is a double replacement reaction because we have compound, 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 and each compound on the left side switches partners to make 2 new compounds on the right side. Hooray. All right, number 16. Number 16 is very similar to number 13. Okay, we're gonna have, we can balance our C's first. 2. We can balance our H's next, which the H's are already balanced. Hooray. So now we have 4 oxygens and 1 oxygen, so 5 total. So we are going to double our initial amount of carbons so that way we can have 4 here and 2 here to balance out our carbons and our hydrogens. So now we have a total of 10 oxygens, and we can just put a 5 there, and now we're balanced. Okay. Again, this is oxygen, carbon dioxide, and water. So that means this is a combustion reaction. Next, 17. We have 2 irons, 1 iron, 3 oxygens, 3 oxygens, 1 aluminum, 2 aluminums. So this one's pretty easy too. We just do 2Fe and we do 2Al, and they're balanced. This is a single replacement reaction because the Al comes in, replaces the Fe, bonds to the O, and the Fe is now by itself. All right, so it looks like, oh man, that's kind of not the greatest spacing, but that's okay. So all of the rest of these are actually already balanced. So I'm not going to go through and count each one of these for you, but they're all balanced. Okay, so we're just going to identify the different equations. Okay, so number 18, we're starting with one reactant. We end with two products. So that is decomposition. Next one, we have element, compound, new element. Element comes in, kicks out another element, and replaces it. So that is a single replacement reaction. Next one, we have two compounds on the left, two new compounds on the right. The compounds on the left switch partners. So that is going to be a double replacement reaction. Okay. Last one, we have two reactants. They come together to make one product. So that is a synthesis reaction. And I believe that is it. Yep, that is it. All right. Good to go.